3. This is the first video. Today is January the 22nd, 2020, where we're going to show how a 630D board is supposed to be connected and configured for an AC controller. In this particular case, we have a motor, and the motor will get self-started at 480 volts AC. So the first thing that I'm going to talk about will be the connections on the board. We're going to talk about the phase references, talk about the output, and the inputs. One of the things we have to make sure is that the three resistors are 37, 38, and 39 are matched for the correct input voltage. For 480, we need these resistors to be 2 meg ohms, and they are 2 meg. We also need to connect the output of the SCRs, each pair, to the SCRs as they are in a rectifier. And we have to bring in power to the board on J3 positions 1 and 2. We're going to need a connection, whether a switch or hard switch, from position 4 of J3 to position 6, which is the 12 volts, and another switch or another connection between 12, the soft inhibit, to common, and we need to bring in SIG high or delay angle command. So those are the signals: power, enables, and SIG high. The phase references have to be properly attenuated, and in the schematic we can see that the different values, what different values should be installed here for different working voltages. So basically this is a 6100 board, but we have to have the connector to the SCR cathodes, the positive SCR, we got to connect to the negative SCRs, and we have to have power, the enable signals, and SIG high. And here's our rectifier, or our SCRs and a rectifier: plus A, plus B, plus C, minus A, minus B, and minus C. The last thing I want to show, it's here, and we have the values for those resistors depending on the voltage. So what we're gonna have here is, here's our 6100 board, the 630D. We have all the SCR outputs going into our SCR controller. Here are all 6 outputs. We have the references coming from the 480 going, and this is very important. We have to have the A going into the A, the B going into the B, and the C going into the C. According to the schematic, the A phase comes on J5 position 1, the B phase on 3, and the C phase on 5. That's important to have the right phasing, otherwise we have problems. We have the outputs, we have the phasing, and the first signal that we have is power. Power has to be applied 24 volts AC between positions 1 and 2. So here's our power, 24 volts. Then we have a connection between 4 and 6. This is instant. Here we have position 10, which is our SIG high. And what we're going to do in this particular case for SIG high, we're going to bring in a power supply. We could use a potentiometer there, but we're going to use the power supply. And that power supply is reference to common. It could also go into position 8 or 11, which is where the common is. Right here. And we have this is going to be the most important one, position 12 to 11, which is the soft start. This is what's going to do all the controlling. And the last thing that we want to make sure is, we want to make sure that we have PP1 right here, the switch configured for a rectifier, for an AC controller. Talking about rectifier, but it's an AC controller. The AC controller, program 1, it's positions 1 and 3 must be open, 4 through 7 must be closed for a zero phase displacement, and position 8 should be open for a 120. We want 0 degrees of phase shift, and we want a pulse rate that is 120 degree long. Again, this is an AC controller, not a rectifier. I apologize for that. So we have it, and then we have the 480 coming and controlling the motor that is here. This is basically the setup, and we're going to power and we're going to bring in the phases, and we're going to show the connections on a second video for a soft start, and we're going to record here a couple of signals that will tell us what we're doing. This is the first of this. This is the end of this first video.